just pipe up. Okay, so we've got these complex numbers. We've got like Z1 equals X plus IY. And let's call that X1 plus IY1. And we've got Z2 maybe is X2 plus IY2. Now, in particular, so this is just the standard form of complex numbers. And what we know is we know how to write that form in what I'm going to call, we know how to write this in polar form. So we've got these polar forms of complex numbers. So this first one, Z1, maybe can be written as the norm of Z1. You can think of it as like the magnitude times cosine of the angle theta plus I sine theta 1. Okay, so there is the what I call the polar form. Now we also have, I could do that with Z2. Yeah, like that. So we have a couple of complex numbers and we wrote them in different forms. Now, remember what we did last time is I actually showed y'all how you can write these things in exponential form. Remember we said this. We took a look at this and we said, okay, e to the ix equals cosine theta plus I sine theta. Okay, this is something we noticed last time. Remember we did those what I call the power series expansions for sine and cosine and e. And we came up with this formula, and maybe you don't remember that, but remember I said, well, what if we put a pi in place of x? And we had e to the pi I equals -1. And remember I talked about how that was so super cool. Well, this though, if you look at it with e to the ix equals cosine theta plus I sine theta, what we've really developed there was not just this coolitry right there, but we also noticed there is an exponential form for these complex numbers. Now, this one that we looked at here is just e to the ix equals cosine theta plus I sine theta. And remember, in that case, we were just acting as though we were dealing with the unit circle. In other words, we were acting as though the norm, the magnitude was 1 of these complex numbers. But you can easily see how that we could rewrite this. You could say this, if z is equal to the magnitude of z cosine theta plus I sine theta. And if this right here is e to the I theta, then we could also write this as z is equal to the magnitude of z e to the I theta. So this right here, that is the exponential form of the complex number. Okay. Now, are there any questions there? Okay. Now, I can't see anybody, so that's not a problem, but just let me know. I'm counting on you to ask questions if you have them. Now, this is something I've not covered in the videos, right? I've not talked about this exponential form of complex numbers. So with this being the case, and this is what I developed last time, remember, we have the exponential form. So let me write that here. Exponential would be like this. Z1 equals the magnitude of Z1 e to the theta 1, well, theta 1i. And then, of course, over here, we would have, well, I didn't allow myself enough room. We would have Z2 is equal to the norm of Z2 e to the theta 2I, like that. So there's our exponential forms. Okay, those are our exponential forms right there. Now, I want to look at something here. Let's suppose, so what I've done here is I have shown you the exponential form of these complex numbers. Now, I want to show you what that enables us to do. So I'm going to give you kind of an overview of some of these operations. And I'm taking a different approach than I did in the videos. Because like I say, those videos, I kind of just kept it pretty basic. This is a little bit cooler than that. If this is the way we can write the complex numbers, you know, if we can write them in these exponential forms, look at some of the things we can do with that. Just take a minute and dig this. Let's suppose I've got Z1 times Z2. In other words, I want to, Z1 times Z2. So I'm multiplying these complex numbers together. Well, if I have them in exponential form, look what that looks like. That's the norm of Z1 times the norm of Z2, like that. And this is E theta 1I times E theta 2I. See? I'm just putting them together. If Z1 does indeed equal this and Z2 equals that, then this is equal to the product. Now, if I have that, look at what this amounts to. If I talk about this multiplication, now, so if I talk about this multiplication, I've just got the magnitude of Z1, the magnitude of Z2. I keep calling it the magnitude, but that's out of habit. It's the norm. When you're dealing with complex numbers, they typically will call it the norm. Now look at this. A property of exponents is we can add them. See? So I had the same base, which was E, and I just added those little fellas together. You know, I just put it under one base and added the exponents. That's a property of exponents. Now, dig this. I write this as Z1, Z2, and then this is, let me factor out an I. Ah, look at that. Okay. Now that we've got that, we're at this stage right here. Look what I can do. Recall that this e to the I theta, recall that that's equal to cosine theta plus I sine theta. Recall that, okay? That, I mean, doesn't take much recalling because we just talked about it. Now, it doesn't matter, it really doesn't matter what this is. This is theta. Well, here it's theta 1 plus theta 2. It's okay if it's that. It can be a sum like that. So look, here's what we have now. We have the magnitude or the norm of theta 1, I mean Z1, Z2. Now, look at this. Cosine theta 1 plus theta 2 plus I sine. I didn't give myself enough room. I'm going to erase this. Y'all deserve better than this. I'm going to write it down here a little bit. Okay. So look, I'm just going to rewrite this down here. Here is what we have. This product is going to be Z1, Z2. Now, cosine theta 1 plus theta 2, like that, plus I sine theta 1 plus theta 2. There. Now understand, what this is saying is this is how we can multiply complex numbers together. We multiply the norms together right here, and then we just add the angles. That's all there is to it. Now, so we take note of that. Now think about this. Think about what would happen if we had z is equal to, let's do the magnitude of z, e to the I theta. Let's suppose we have something like that. Now right here, we've just developed the formula for multiplying two complex numbers together. Now, let's suppose that we want to raise a complex number to a power. So let's do this. Let's suppose I want to find z to the kth power. Well, that would mean this whole side over here is raised to the kth power. See? Raise, z to the k is the same as this thing to the k. Now let's see what that looks like. That would be the norm of z to the k times e to the k theta I. See, I just raised both of those to a power of k. Now, remember, z is also equal to, in polar form, cosine theta plus I sine theta. And we just noticed this, right? So look, this right here that we just did, it has a polar form. Now, remember what the polar form is. The polar form is when we take this part and do cosine of that plus I sine of that. So just, and this may be something you have to think about a minute, but this is going to be z to the k times cosine to the k theta plus I sine k theta. There. So it looks like raising a complex number to a power like k just involves multiplying the angle by k and then raising the norm to the k power. Now, you can also, so let me give you let's suppose we've got Z1 and we've got Z2, okay, Z1 and Z2. So let me just kind of summarize this. Z1, okay, here we go. We've got the polar form. Okay, so let's suppose, let me just go back here. I want to kind of summarize this. Let's suppose we've got Z1 is equal to the magnitude of Z1 e to the theta 1 I. Okay, that's one form. And then we've got Z1 is equal to, so this is the polar form. Okay, so there we've got the exponential form, the first thing, and the second thing is polar. Now we've also got Z2. Okay, there's that. And then we've got Z2 is also equal to the magnitude, or the norm of Z2 cosine theta 2i, theta 2 plus I sine theta 2. Okay, now, so if we've got these, now, so what I want to do here is I'm just going to kind of summarize a bunch of these formulas for you. First of all, if we multiply, okay, so let's suppose I multiply Z1 times Z2. Let me move this over just a tad. There we go. Okay. That's equal to the magnitude of Z1, magnitude of Z2 times e to the I theta 1 plus theta 2. That's exponential form, if we want to look at it in exponential form. Polar form, so this is just me summarizing now. Okay, there's the polar form. Now, if we're raising either one of those to a power, so this would be and that's 1. Okay, or okay. Now I'm going to show you an example of these here in just a second, but let me know if any questions pop into your mind. Okay. Okay. Now it just occurred to me I'm going kind of fast, so I need to calm down. But I'm also recording this, so it won't be so bad. Okay. Okay. Now just pop in here if you have any questions. Okay. Now, also, we've got this. Now, if you think about this, if you go through the same way I developed the multiplication, we've also got this division. If you take Z1 divided by Z2, that's the same as Z1 over Z2 e to the I theta 1 minus theta 2. You know, if you think about it, you would see that, yeah, that's going to work the same way. If you go back and look what I did for multiplication, this division will work the same way. Now, of course, in polar form, you would have, and I want to pause a minute and let you think about what that might look like. I don't want to be a jerk and ruin it for you. Okay, so this is going to be cosine theta 1 minus theta 2 plus I sine theta 1 minus theta 2. There you have it. Okay, so these are the basics. Now, what I want to do, I want to show you examples. I want to go through an example and show you how this would work. Now, are there any questions though before we get going here? Maybe I can look over here and see any questions. Okay, it doesn't look like I got any questions here. Okay, so let's see. Let me come up with a couple of complex numbers here. Okay, so I'm going to hang on a minute. No, okay. Okay, here we go. Let's suppose that I've got Z1 is equal to, let's say I'm going to say 4 plus 4 square roots of 3I. There it goes. That's good. And I'll say Z2 is equal to 1 plus, no, let me not make it that way. Let me make it square root of 3 plus I. Let me do that. There's a Z1 and there's Z2. Now, the first thing I want to do is, hang on. I gotta chat here. Let's see here. Okay. Okay, in the start of the equation, is it supposed to say, it's supposed to say Z1. I'm sorry, Z sub 1. Someone asked that. It says in the start of equation, is it supposed to say Zi or Z1? It's supposed to say Z1, Z sub 1. Yeah. So here I have Z sub 1, there I have Z sub 2. Okay. I don't know if I cleared up the question, but we can explore it more as we go along. But here are two complex numbers. Now, what we want to do first is we want to convert these to polar form and exponential form. Those are the two things that we're going to need to do. Now, so here I go first of all. Okay, so let's look at this one. I need to find the norm of Z1. So that's going to be 4 squared plus 4 square roots of 3 squared. This is how we get the norm. Now, that is going to be 16 plus 16 times 3. Okay. Now, norm, so, I didn't need to do it like that. What is that going to be? Is that 64? I guess. And it's 8. Yeah, there we go. So there is the norm. Now, the next thing I want to do is I want to get theta. I want to get the direction. Like when we were dealing with vectors, this would be the direction of the vector. And there's really no difference in how we're, what we're doing here. Now, if you were in quadrant 1 or 4, arctan is what you can do. So we can do theta 1 is equal to arctan, the y over the x. Now, this is just arctan of the square root of 3, and we know that to be 60 degrees. Okay. Yeah, from the unit circle, because on the unit circle, sine is square root of 3 over 2, cosine is 1/2, so square root of 3 over 2 divided by 1/2 is the square root of 3. Okay. Now, that being the case, we can now write our complex number. Z1 is equal to 8 e to the, and let me just use 60 degrees here, although I could use pi over 3. I think what I'll use pi over 3. Let's keep it in radians. Pi over 3i. There we go. Pi over 3i. Since calculus, we only use radians pretty much. Everything is done in radians, so I'll just get us used to that. Okay, so there's that one. Now, also, we could write that as 8 cosine pi over 3 plus I sine pi over 3. So look, here is exponential form, and here is the polar form. So we need to be able to do both. We need to be able to put it in exponential form, and we also need to put it in polar form. Now, remember, you have to be careful when you're finding that direction angle. If when you plot the complex number, if you're not in quadrant 1 or 4, whatever arctangent gives you, you need to add pi to it, or 180 degrees depending on if you're in radians or degrees. Okay. And if you get a negative number, let's say you're in quadrant 4, arctan is going to give you a negative number. If you don't like that, you can just add 360 to it or add 2 pi to it and get a coterminal angle. Okay, so we've got that. Now let's look at Z2. Z2, we're going to get the magnitude of that one. Which is going to be the square root of 4, which is 2. The real part is square root of 3 and the imaginary part is 1. Now, as far as the theta goes, it's going to be arctan of 1 over the square root of 3, which is 30 degrees, or pi over 6. So now we have this. We have Z2 is equal to 2e to the pi over 6 I, which is 2 cosine pi over 6 plus I sine pi over 6, like that. Yeah. Now, are there any questions? Let me know if you have any questions. So sometimes I don't always see when comments pop up, but okay. So okay, now. So our first task in finding these complex numbers, or doing work with complex numbers, is we're going to change the form, either polar or exponential. Now, let's just do some things here. Let's suppose I want to find Z1 times Z2. Okay, so that's going to be 8 times 2 cosine pi over 3 plus pi over 6 plus I sine pi over 3 plus pi over 6. Okay. Now, if we wanted to represent the answer in exponential form, this would be e to the I pi over 3 plus pi over 6, like that. So we've got two forms that we're working with. Now, we've also got Z1 divided by Z2. Okay, so that's going to be 8 divided by 2. I think I got them straight. Okay, yeah. And then this is going to be cosine pi over 3 minus pi over 6 plus I sine pi over 3 minus pi over 6. There we go. Okay. Or exponential form. See, super easy. You know, once you get one form, it's easy to go back and forth. Okay. Now, and of course, we would work those out, you know, but I'm leaving it like this so you can easily see what the angle is. In other words, pi over 3 minus pi over 6, we would go ahead and work that out. But now, let's look at this. Let's suppose I want like Z2 raised to the 6th power. Z2 raised to the 6th power. Well, that's going to be 2 to the 6th power cosine of 6 times pi over 6 plus I sine 6 times pi over 6. See? Because remember, this right here is Z2. So I just multiplied, I raised 2 to the 6th power and then 6 times pi over 6. Okay, are there any questions about that? Okay, are you ready? I'm going to stop the share here. Let me know if you need me to leave it up there. Let's see here. Okay, okay. Share is stopping in 3, 2, 1. Okay, any questions about any of that stuff? Okay, so this is something extra. This exponential form, since I developed it last time with the power series and all that, that's something not typically done in trig. But we do things that are not typically done in trig because y'all deserve it. Are there any questions?